Hocam mülakat sorularını ChatGPT'ye hazırlatabilirsiniz aslında.
Ya o kadar kompleks sorular sormayacağız herhalde. Gene de bir hazırlatayım bakalım. Ne yapacak?
Hocam Pro'sunu
Şey falan
kullandınız
sor.
mı?
Neyi?
Pro'sunu da kullandınız mı ChatGPT'nin?
Aylık 20 dolar verilen yerden mi diyorsun?
Evet hocam. 20 dolar.
Sen verdin mi?
Hocam 2-3 arkadaş 10-20 arkadaş toplandık. Bir tane ChatGPT'ye kurbana girer gibi. Bu ekonomide. Bir denedik hocam. Bir ay
Peki
güzel çalışıyor.
peki farklı mı çalışıyor bedava versiyona göre?
Ya beklemiyorsunuz hocam. Bir de daha zeki.
Daha zeki.
Evet.
Enteresan.
Hocam iki versiyonu cevaplıyor. Birisi çok daha hızlı cevaplıyor.
Ya hız hadi neyse de sürekli kullanmıyoruz çünkü. Ama cevabın kalitesi iyi ise verilmeyecek bir para değil. ...20 kişi kullandığınızı anlarsa ne yapacak? Anlayıncaya kadar kullanırız diyorsun.
Gmail ile giriliyor hocam. Bir Gmail ile birden fazla
İyi
opsiyon
de
oluyor.
adam zeki, bu soruları bir kişi soramaz diye anlayabilir yani.
Hocam muhtemelen banlanacağız zaten de yani.
Tamam. Ekranım geldi mi?
Geldi hocam.
Tamam. So today I am going to talk about information visualization, data visualization, which is becoming a hot topic after the big data explosion. So we will be doing some introduction, some principles, some examples, and we will think about some design issues. We will be talking about different designs. First graph visualization has been found in 1786 by William Playfair, describing time series data about European trade. So the area in between shows the trade deficit over the years. So it was an interesting graph, and it is William Playfair is generally viewed as the inventor of the common graphical forms today, like line plots, bar chart, and pie chart. There are interesting graphs over the history. One of them is Napoleon's March, the weather map, and the century of meat and baby named Voyager. Let me show the Napoleon's March graph. This is Napoleon's March. It looks like an insect from distant, but the left part is Paris, and on the right we have Moscow. As Napoleon's army is going to the Moscow in 1800s, the thickness corresponds to the number of soldiers. So as they go, a lot of soldiers died, and when they come back, remaining soldiers died, so very few soldiers returned to home. And the graph shows the time and the temperature. At the bottom there is temperature, dates, and also geographical relations at the same time. So it's an interesting and famous graph about the Napoleon's march to Moscow. Visualization is kind of interesting definition to form a mental image of something, to imagine or remember as if actually seeing. So you don't have it, but visualizing it as if you have seen it. So it's what visualization, three-dimensional visualization, data visualization. So those are like, it is not actually there, but you see it as if it is there. Action or fact of visualizing, the power or process of forming a mental picture or vision of something not actually present to the sight, a picture thus therefore formed. Action of process of rendering visible. Information visualization, transformation of symbolic data into geometric data. So you have symbolic data, numerical data, and transforming that data into geometric one is visualization. That's one definition. Finding the artificial memory that best supports our natural means of perception. So there is an information, but if you find the best supporting perceptive tool, which is visual, then it is visualization. So it is the interdisciplinary study of the visual representation of large-scale collection of non-numerical information such as files, lines of code, and software systems. That's what Wikipedia says. Giving information using spatial and graphical representations, bringing information to life, the use of computer-supported interactive visual representations of abstract data to amplify cognition. So this is the definition of HCI people. Hart, McKinley, and Schneiderman. So we will focus on computer-supported interactive visualization. Also, another definition, graphics, Pat Hanrahan said, the use of graphical techniques to convey information and support reasoning. So a lot of different issues arise here, including design, statistics, mapping, big data processing, etc. So all of them are relevant. There are types of data visualizations. The famous and easy one is the chart. There is also map with the spatial X and Y relations, coordinate relations. It could be Z too. It could be network, meaning that connections. It could be hierarchical visualization, time visualization, Ocak, Şubat, Mart, Nisan, and textual visualization, which is recently famous for their use in big data. There are information visualization, scientific visualization, data visualization, information graphics, and visual analytics. So 5 different types. There is an information visualization versus scientific visualization. When you are trying to find new things, it is usually scientific visualization. But when you are trying to convey some information, send some information to somebody else, give some information to somebody else, then it is more like information visualization. These are the examples. The difference is when scientific visualization is more like for research. Information visualization is for development. So in the information visualization, how to represent is chosen by you. Spatialization is chosen and you think data as a collection of discrete items. So you have the data and you conduct data. The scientific visualization, the specialization is given. It is given and you think of data as samples from a continuous entity. So it's more like analysis. Data visualization is more like information visualization. It's the study of the visual representation of data, meaning that information that has been abstracted in some schematic form, including attributes or variables for the units of information. There is a Wikipedia page for data visualization. It is very nice, so I will suggest you to go there and check some introductory material and links. Infographics is an interesting topic. So it is for giving some explanation and information to the audience. It is the visual representation of information, data, or knowledge. You don't want to discover new things. You want to explain things. So the graphics are used where complex information needs to be explained quickly and clearly, such as in science, maps, journalism, technical writing, and education. So it goes to pictorial representations, such as let me go back to the browser. So these are typical infographics examples. Okay. These kind of, they also sell these items in stocks. This is This is an infographic. So anything that relates data with the graphic designs is called as infographics to convey information to the audience. Okay, these are all infographics. They are used extensively as a tool by computer scientists, mathematicians, and statisticians to ease the process of developing and communicating the concept of information, such as this, the earthquake information. So data will be explained by graphics and text together to give some explanation to the reader. So information assimilation becomes much easier if you see it and read it together, because the power of visual comprehension is used. This is infographics if you know the result. If you don't know, then we call it if you don't know, then we call it visual analytics. That means with the infographics, we know what to say. If we don't know what to say, if we are doing search of patterns and search of the data, then it is visual analytics, the science of reasoning with visual information, pairs machine intelligence with human intelligence. So with visual tools together, we can analyze the data. Then it is named as visual analytics, like selecting close by elements as sets, etc., or dividing the data set into two from certain regions, slicing, selecting, filtering, coloring. Those are visual analytics tools. So this is from the book. So a map with temperature readings from sensors, map with population information, census data showing household income versus highest education as a table. Same data without the map or with the map. Let's see. There is, so obviously, map will be much better. We have elections coming. Okay, so giving information based on the data is quite powerful. Okay, it's quite powerful. These are all map-based data visualization. And we will see that significantly next week. We have a periodic table. I haven't shown this to you before. It is periodic table of visualization methods. So please write that in your own machines. At each location, there is a type of graphics. On the left, there are primitive ones, such as continuity, tabling, pie chart, bar chart. histogram, box plot. So these are fundamental types. Then there are extended Cartesian coordinates, line chart, area chart, scatter plot, spectrogram. Then you have radar chart, Sankey diagram, data map. Sankey diagram is the Napoleon's march. Parallel coordinates, information lens, tree map, hyperbolic tree, entity ER diagram, bone tree, cycle diagram, Petri nets, system dynamic simulation, timeline, flowchart. On the right, we have more abstract swim lane diagram, communication diagram, meeting table, project underground, temple, concept skeleton, perspective diagram, concept, dilemma diagram, parameter ruler, knowledge map, rich picture, cartoon, graphical facilitation, infographics, roadmap, spray diagram. So these are all different types. So it's a good example to have everything handy. These are all kinds of data visualization techniques. So once you have seen these and you have data, then each of them has advantages. And the colors are corresponding to data visualization, information visualization, concept visualization, compound, metaphor, and strategy visualization issues. So depending on your need, you can browse here and select an appropriate visualization technique. Here, with the help of the visualization, we increase the capacity of the working memory. So our memory is now more powerful, temporarily, of course. Inference is increased. Search and discovery is more successful. It's more communicative, giving more information to the other side. And if it is interactive, it also allows manipulation. So visualization is really powerful. It's really powerful. If we consider everything as information visualization, but recognize important high-level differences, like is it localized spatially or in time, or both? Is it interactive or non-interactive? Or is it going to present some message, or is it going to be used for the research? Do we know the result or we don't know the result? For example, it's a typical pie chart. Tells you who gets what. So who gets the bigger share? It gives significant information about it. So it is kind of prepackaged because you know the data, but you want to represent it that way. If you don't know what to say, then it will be an exploration tool, analytics tool. In the last 5 years, increasing representation of everything is found in digital form. Therefore, almost all data is becoming visualized lately. So visualization is very hot topic. It is actually beyond the scope of this course. There are courses named data visualization courses given as a separate class in some departments. Information visualization brings different disciplines together, such as drawings and graphics, communication, computer science, psychology, HCI, together. So there is an art part, and there is a psychology part, there is a computer science part, and there is also statistical and mathematics part. And we guide the design and evaluation in this process. It is increasingly important because without visualization, data is becoming too much. Too much data is not understandable. So only by visualization, we can understand it. Our brains are limited in power and data is increasing. Therefore, we have to visualize it in order to understand it. It is shown to improve how well we understand data and how quickly we can understand data as opposed to doing it manually. The amount of data is really big. So there is also scientific data coming from telescopes, atomic colliders, medical data, and microarrays collectors, and weather observations. So science data is also significantly large. So in order to analyze these data, you have to make visualization tools. Otherwise, in Excel files or CSV files, it becomes impossible to understand it. Astronomical data is increasing. Over the years, we have a new telescope in the space, and that is sending data, and that is also visualized and processed, colorized, so that we can perceive them as galaxies and distant objects. Medical data is increasing, and three-dimensional visualization is becoming popular in medical imaging, also colorization, and recently artificial intelligence also helps doctors to analyze these three-dimensional models together with the doctor. So there is a cooperation between artificial intelligence algorithms that process these medical data. And obviously, it is done through visualization. Genetics, genomic data, proteomic data, protein data, they are all good for research in genetics. These require visualizations. Also, drug design requires visualizations. Data is increasing, agricultural, biomedical, environmental, engineering, manufacturing. So we are here and data is coming on to us. The difficult part is analyzing them and extracting results and understandings from that. Otherwise, it's too much. In the 21st century, the work, any kind of work requires some kind of computation, some kind of theory behind it, and some kind of experimenting together. So same thing is true for data visualization. We have large data sources. We have some theory. And we also have some field work, field data structures, so that we can experiment it. There is an infographic example. When you show this to people, this is how each different meal, if you eat this, it goes to your pot using these ingredients. These are the environmental impact of it. So at the end, you will get some food out of it. So if you eat beef, for example, etc., it's at the top. So environmental impact, etc., is larger. So that when you eat this, your contribution to global warming, etc., can be understood because these are the ingredients of this dish. Suddenly, you start deciding what to eat based on the ingredients. So it's basically a communication tool and comprehension tool. It helps to understand things much better. And sometimes it is used for discovery in scientific visualization. In business, it is used for decision making. For example, you visualize it and you understand it. And you understand that the stock market is going down. Therefore, you make a decision after seeing the visualization. Okay, it's very difficult to analyze it without visualization. Therefore, let me show. So tree map is one thing. Weight map, line charts, bar charts, these kind of issues. Okay. Tree map is something. This is another thing. Color is important in these, etc. Another one. Tree map within the tree map, so energy, etc. Tree map is significantly used. There are variations like this. Okay. Another one, three-dimensional tree map. So it is used for decision making in stack map visualizations. The goal-based division of information visualization is, on the one side, you have illustration and communication purpose. On the other side, as I said, exploration and discovering and decision part. So here you use it for your work. Here on the left, use it for people, to make people understand your work. So it's for explanation. If you know the answer, it's for presentation. If you don't know the answer, It's for scientific visualization and exploration and decision making and analysis. Analysis, monitoring, planning, communication. Tufte set, description, exploration, tabulation, and decoration. There are other people said it aids to thinking, problem-solving, decision, and insight and clarification, etc. So visualization should make large data set in coming together, presenting large amount of information in a compact form, and also present that information from different viewpoints, like this way, if let's look at this way, let's look at that way, etc. So next week we have the elections, and we will be seeing different visualizations showing different perspectives of the same data. Present information at several levels of detail, from overviews to fine structure, supporting visual comparisons, and telling stories about the data. So through the explanation. It helps to utilize vision system for processing, vision system of human for processing the tasks more quickly and more naturally. So that is easy assimilation. It enhances the memory by using external representations, supporting the cognition by decreasing the load on working memory. So what is the result? 36. So I am doing this by writing because it makes me visualize the computation. If I don't visualize it, generally I have to create the same image in my memory. So it becomes a little more difficult if I don't visualize it. Visual representation may be more natural and efficient way to represent data or problem space, such as visual languages or symbols, instead of spoken language. So visual language, like go there and turn right and then click. So this is easy to explain. Go straight and turn right is easy to explain than saying it with words. So graphical explanation, visual representation of things is much easier. We are using people's capabilities in scanning, recognizing, and remembering images. So anything we use with known elements like different shapes, different textures, lengths, these are all relevant and can be used to construct a graphical visualization. So length, shape, orientation, and texture. Also, we can have animation. We can have different colors. Also make the aesthetics so that people like it. If you like an object, you look more. And if you look more, then you will understand more. When mental models are formed, that means internal representation. And there is also external representations. We call them cognitive artifacts. It becomes together, and we call it as distributed cognition. Different representations have different cost structures and running times. For example, this is one representation. This is another representation. This is another representation. Distances 4. So in order to understand these correspond to the same quantity, the cost structure is different. It's a big idea in computer and cognitive science to present information in the correct way. Visualization helps to understand things, such as we can discriminate different things, different issues. We can estimate quantities, saying that one side is larger than the other. We can segment objects into groups by visualization. We can remember, so it changes from recall to recognition. And chunking is enhanced and transform a more memorable form of data, so you can memorize it. Mesela Maslow'un triangle'ı vardır. Maslow'un triangle'ı dediğinde üsttekilerin az olması lazım, alttakilerin çok olması lazım, önemli olması lazım sayıca. Demek ki ben ne koyacağım? İşte alta barınmayı, beslenmeyi koyacağım. Daha sonra işte kendini geliştirmeyi, bilmem neyi. Bu üçgen olduğu için benim bunu hatırlamam daha kolay oluyor. So it reduces the search time in human brain. Retrieving information in neighborhood is easier. Its natural index, such as if it is spatially related, something is here, something is here, something is here, and another one is here. So if you look at this, you probably estimate that the closest one is the spatially closest one because it is drawn in a near space in spatial index. So searching is amplified, searching becomes easier if you visualize the data, also with the color. Having map inference to visual pattern finding is helpful. Also, we can enforce constraints. We will have an example. We can highlight to focus attention to where we want. We can control where to read by the user. There will be some style differences, also giving an aesthetics, and giving alternatives encourages creativity in visualization. So only fixed data is more difficult. So let's see some examples. This is one example. You have numbers, but size of the balloons do not correspond to size of the balloons. Therefore, it's misleading. It's misleading on purpose. This is quite incorrect. Another one, number of doctors in United States per family. So they claim that it's going down, it's shrinking significantly. However, the size of shrink is not the same as size of the doctor. They kind of amplified it. Making informative graphs is to avoid confounding design variation with data variation. This means that changes in the scale of a graphic should always correspond to changes in data being represented. This graph violates that principle. They violate it on purpose for political reasons. This is also typically changing with the axes. The numbers are not equally spaced. For example, 39, 47. So almost 10 years in between. 55, 63, almost 10 years. 67, 70, but then 72, 73, 74, 75, 76. So here, these are 1 year, 1 year, 1 year, 1 year differences. So this is, although this is kind of linear, in reality, it's not linear. It's more like this, because late years are yearly spaced. Early years are not yearly spaced. So playing with the axes disturbs data visualization. Another interesting graph, interface that students use to begin their search process by Google or by library homepage. So some of them is always be, some of them will always be 100%. So bar chart is wrong. This must be done with the pie chart. This will be Google. This will be library. Okay. This is hard to understand. Another use of infographics. This one says with multiple colors, multiple fonts, it's hard to correlate which one corresponds to what. Obviously, there is some relation, but the relation of color with the content is not clearly understood. So relation of color is not clearly understood, and there is no legend either. So why it is helpful? There is also crazy visualizations because, as we said, it amplifies our cognition. It amplifies for understanding. So let's do this 647 by 58 in the head, and second one on the paper. Elde var 5, etc. So this is a visualization. When they do the experiment, when mental arithmetic is required, it took 50 seconds on average for multiple subjects. It took less than 10 seconds for people with the pencil and paper. So obviously, paper and pencil is much faster because visualization aid is really significant. So it's basically 5 times faster with the visual aid. The experiment is done by the Schneiderman's team by CART. So therefore, we built tools to amplify cognition. Challenge. Yeah. Another challenge. How to prove that Pythagoras theorem is correct. So by visualization, you can ask students to count number of triangles. Okay, number of triangles in the squares so that they can correlate these two. Sum of this a square plus b square is equal to c square. So the area of these two will be equal to this because number of triangles inside the rectangles are the same, will be the same. What is the highest temperature in United States? This is the highest temperature because it's hottest. It is the red. So querying based on data map is very easy. So sometimes giving oral instructions, written instructions, graph drawn on paper, and any kind of visualization of the people's choice. This one is faster, this one is slower and vague, meaning that it can change, people can forget, etc. or trip directions. And let me show the subway map. It helps to people finding their ways. Also, there is a cholera map, which is very famous in the history, and there's a Florence Nightingale map, which I'm going to talk about. And subway map. There is a spatial relationship. Also, there is an information about route and stops. It is not 100% spatially related. It is partly related. There is an abstract version. So this is the early version of London subway from 1927. In 1927, this was the map. So it was more bounded to the shape of the railroad underground, so that you will understand that there is a bend somewhere. Also, this goes to northeast, this goes to north, and this goes to south, etc. So the orientations, there is also a river here. So all information is given in the same map, but geographically, it's not accurate on purpose. That's the new map. New map is the extension of the old map, but the format is changed. Geographical connection is reduced. River is there. Orientations and directions are usually the same. There is also additional information about the interchanges with different symbols. So different symbols, names, and colors becoming important, although we also have legend here. Number of legend items slightly increased. And similarly, let's move to Istanbul map. Istanbul map is similar this year's, and also in Moscow map. So metro map standard is relatively developed up to some point across countries. So when you visit another country, it becomes very easy to accommodate with the new metro map if you are familiar with the old metro map. So driving directions also shows how complicated the human representation is in the brain. So directions or map becomes much easier. So if you visualize the directions, you don't need to follow turn by turn directions. You just estimate where you are going. And also route is also chosen there, and that will be more helpful. There is an exception without showing the surroundings. This is also doable, but showing the map is giving more information to you. Showing the satellite picture is better for correlation of the surrounding objects. So it also amplifies the cognition. You can show the picture as well. This is for fun. So at the end, you have to see this in the windshield, in the front of the car. So in 1854, there was a cholera outbreak in London, and they couldn't find the cause because the microbe was not known well in those years. So they plot number of dead people in the map and understood that number of deaths increase as they approach this location, and then they realized that there is a water source here, and this water source was dirty. People who are using this water was dying. So they used data visualization to understand the cause of the death caused by bad water pump. This graph is taken from Edward Tuft's book named as Visual Explanations. There is also Florence Nightingale graphical representation. Florence Nightingale is also famous in Turkey for her work in Turco-Russian war in Istanbul. Because in Turco-Russian war, we were fighting together with Britain. So Britain was ally to Ottoman Empire in those years. She is remembered as the mother of nursing, fine, but we also realize that in history, like William Playfair and others, she developed some graphical methods for representation of data, and namely medical data. She used Coxcomb plots to show that more deaths were attributable to non-battle causes than battle causes. It is important for its display of frequency by area, like the pie chart. Unlike the pie chart, Coxcomb keeps angles constant and varies radius. Here is the example. The mortality rates in the army in the East in 1854, just before the Turco-Russian War. So battle deaths are blue and non-battle deaths are red. So apparently non-battle deaths are much more significant in the army. So they have to improve the conditions of soldiers so that they don't die in the military. Similar data visualization problem in Challenger disaster. Let me show you what Challenger disaster is. Maybe you're not. Challenger disaster happened in 1988. There was a space shuttle program, and space shuttle exploded, and because of some, this is the space shuttle, And these are the people who died in the accident. After this accident, space shuttle program was canceled. And then later, Russians were started to take people out. And these are ice. And okay, this is after explosion, the air. The okay, Richard Feynman actually. I'm not going to.
Ever wonder why so many people say they want to learn guitar, but very few actually learn to play? I think it was the first public hearing. You took a glass of water and dropped a piece of.
Okay, so I put it in the chat. You should watch it. You should watch all of it. Okay, because it applies to other disciplines. The general problem, it applies to other disciplines, but the cause was attributed to data visualization in catalogs, because in catalogs it was not understandable. It wasn't understandable that the O-ring, the failing component, is going to fail. It was, the data was there, but it was hard to understand. Therefore, design team didn't realize it. So if it was, this is the O-ring. Oops. If it was represented correctly, then it could have been found before implementation. However, they couldn't find it in the design and implementation, and they found it after the explosion. And the people who found it, the person who found it is Richard Feynman, the famous Richard Feynman found the cause. So tables are good, but for easy understanding and assimilation, it could be difficult. So this is the difficult part. Highest college degree. So you have to make a linear search because it is sorted based on the place and state. It's not based on the percentage. So when you ask a more difficult question, income and college degree. So you are going to make a combination. You are going to divide A over B. Okay. So income and college degree, are they related? So you are going to make some relation between college degree and income. So it will be very difficult. However, if you plot it on the horizontal axis, you have the income. In the vertical axis, you have the degree, percentage degree. Then you immediately understand Nevada is significant, Utah is significant, District of Columbia, Connecticut is significant, and also Mississippi is significant, low education and low income. Automatically, you realize that These are outliers. These are a regression. This is the regression line, and these are not outliers, but low income, low degree, high income, high degree is there. So that is how you represent data graphically. With the tables, it becomes very difficult. Okay. So the big picture is usually more important, and with the graphical visualization, you can achieve that in a quicker way. Edward Muybridge made a graphical representation, which is animation, helped to understand whether four legs of the horse touches to the ground or not. Let's click this link. Okay, this is the animation Muybridge of the Muybridge. So you see that in some time all the legs are up. So this is visualization of real data. There are Second Life, metaverse, and other kind of visualizations for artificial life experiences, virtual reality experiences, for training, for army, and for medical simulations. It allows physically enabled person to move in the world, or fear of height, for example. So virtualization, virtual environments, visualization of virtual environments is a whole different topic. 3D visualization, and it has also its own domain, three-dimensional visualization domain for the virtual reality. That's different from data visualization. However, that's also data. The famous tree map invented by Ben Schneiderman in 91 shows the hierarchy in three-dimensional layout. It fills up the space with rectangles, and there will be nested rectangles, and the sizes correspond to the size of the data. Here is the example from the original paper. There is a hierarchical tree in the file system. This file system, based on the sizes of the file, can be shown in this way. So each one corresponds to certain hierarchy. So I can understand both hierarchy and size of the file together visually. So if I am going to delete a file, I delete this file if it is unnecessary, because that takes up the most space. I immediately recognize it. Another example from 91 of the Schneiderman. Another example. And there are also problems because those are rectangles, and such as adjacency means nothing yet. Aspect ratios are uncontrolled. You can play with it, so you can generate modifications. and color is not used appropriately sometimes. And if you do it in large data sets, it may not give any information, just the crowd. So if you are going to use tree maps, you need to use a proper data. So it should fit into the domain of the information. Successful application of tree maps are finance, where color has some meaning, like increasing price or decreasing price, hot, cold, new, old, and size also, size relationship, price relationship, importance relationship, so or population relationship is associated with the hierarchical organization, hierarchical different kinds. Also, it can be done in interactive way. So if you go over it, it can explain different things, or if you click on it, it can go into deeper level of the tree map. There are different versions of the tree maps. Many people worked on it, so that can be used to visualize complex big data today. And this is a financial example from smartmoney.com. We call this as market map. This can be animated. This can be animated to show different information. Also, you can support it with additional information, such as you can put certain signatures here, certain things here, and they also indicate certain information. For example, you can put arrow here. You can put arrow here or some mark here, star here. It also gives additional information, or blinking light somewhere in the box. It also carries additional channels of information. This is one example of tree map in the shopping site. These are the items in the coffee selector. So if you want to order decaf coffee, you click on this, and if, American's coffees there are 3 types of coffees, and you click on this, and the certain sub menu appears. So it is used as menu. Most frequently used things are coming as big boxes. For example, when you go to an İskender kebapçısı, you may also have kuzu shish, but many people are eating İskender, but some people are using kuzu shish, and some other people are using salad, and some people are eating some other things, çorba, etc. So this is how menu is divided. So you will immediately recognize that this is İskender, and so you also want İskender because many people are eating this. So if you want something like this, and tree map is a good idea. Yes, when you go over it, it has explanation. Market maps use of tree maps allows the sophisticated analysis of data. Pitt's use of tree maps is more for presentation and communication, the previous one. So there's a contrast. For one is for analysis. The second one is for communication and using as menus. So college tuition and Okay, this is college tuition. When you make a graph, you automatically understand it, but if you don't visualize it, you need to check visually one by one how much it is. And if the question is complex, like tuition increases at 6 universities over the 5 years, there are also cheap ones, there are also expensive ones, but you are interested in the increase. So you can convert it to percentages. Percentage increase will be an option rather than absolute values. These are absolute values. So many creative ideas can come up, but at the end we end up with pie charts, because the hard part is how to apply it correctly. Inventors usually do not accurately predict how their invention will be used. Many people try for cool looking, exaggerated visualizations. This is not good. So there are visualization problems, and this is from the book. And testing, developing, and evaluating visualizations help to understand in a deeper way. In some areas, there is no generalization. It's kind of an art. Does it sell? Yes. It's a hot area. There are new visualization techniques and tools. Not many people from our country is developing visualization tools. Many people are using visualization frameworks to make visualizations. So very few people are, maybe nobody is developing a visualization tool from our country. So, but keep in mind that there are some people developing visualization tools. Not everybody is using it. Obviously, number of people who are using the visualization tools is much higher than number of people who are developing. However, there is an explosion of interactive visualization in every area. So the content of the interaction with the computer happens in some display, virtual worlds, graphic design, techniques, design and evaluation. This is ICI part. So the information visualization, all these includes the following. One example visualization is number of visits to library during the last year by the different people. So number of visits to library reduces significantly if you are a professor. If you are assistant professor, you don't go to library that much. If you are student, master student, you go too much. If you are doctoral student, you go less and less. And reading hours increases when you are associate professor, and then decreases when you get the full professorship, because you are getting kind of older. When we have big data in front of us, big data visualization comes up. In the right picture, what is right conceptually, perceptually, graphically, and also politically. the conceptual point of view, for example, there is a relation between price and weight of the car. So is weight cause of the price? Actually, no, but there is a correlation. So correlation doesn't mean cause. So these kind of graphs may have a misleading conclusion. You need to be careful about it. R square is quite significant, but it's not the cause. For example, if you are a coffee drinker, you are more likely to make traffic accidents. So that means if you stop drinking coffee, will you make less accidents? No. It's a relation, but not cause. Also, connection of line charts is wrong. When you have Ocak, Şubat, Mart, Nisan, you can connect. So if the horizontal axis is time axis or a continuous variable like time, then you can have different measurements over the time. But here you have smartphone, tablets, notebook, middle, smartphone, tablet, notebook, mobile, and in different regions. So you cannot connect it like this. Okay. Also, quarters are given as different lines, which is also completely incorrect. So it is very easy to screw up perceptually correct designs. This is also graphically incorrect, maybe politically, because there's an 18 here and there's 27. But when you compare distance, the ratio doesn't match. Ratio is actually not much smaller than 27. So although this looks small because it's perspective image, actual data is a lot bigger. So this is graphically incorrect, but politically maybe correct. And the ratio of the distortion, the book called it as Lie factor. Size of effect shown in graphic versus size of effect in data. If they are not equal to 1, if the result is not equal to 1, then there is a lie. And there is a lie factor here. Lie factor is 14. Politically, perception. If you want to show that many places are Republicans, this is good. If you want to show that many places are Democrats, this is good. Both of the data is correct. So graphically, it's correct. Data-wise, it's correct. But politically and perceptually, they give two different meanings. This is also different. Okay. So when we have playing with big data, in addition to volume of the data, there are other constraints, such as real-time changes in data variety of the sources, so data will be dirty, and different levels of data structuring. It's not easy to represent big data because there are a variety of data sources, there are a variety of different data structures, and also it is changing rapidly. It's not static usually. Why it is becoming big, and when do we call it big data? If we cannot store it in database, then it's big data. The standard database storage becomes impossible for big data problems. We represent the rich visual world of experience, but we are on the flatland. So the paper is static, the display is static, the world is complex. Therefore, we need to find, it's basically a projection of reality. Projection of real world data into two-dimensional or three-dimensional space. For that to work in the big data, first you collect it, then you clean it, then you integrate it, visualize it, and make data analytics, usually present data and get the results. So without dissemination and presentation, analysis is not helpful. Only visualization is also not helpful. You need to provide analysis tools. You need to make analysis in order to get benefit from the visualization. These are the same steps. First, there is a data cleaning and integration and analysis, then interpretation. So big data visualization in big data lifecycle is in many steps, starting from pre-processing, filtering, handling, exploration, and presentation. You may use the data visualization in data reduction, or in analysis, in visual interaction, or in reporting. There will be automated analysis tools for that, interactive visual methods that you can program. There is visualization techniques, and there's also traditional visualization techniques which you can program. And there are presentation tools, reporting tools, and analytic platforms by big companies that you can use, like SPSS, SAS, or other framework developers. There is there are 5 V's of big data. We will talk: volume, value, variety, velocity, veracity. Volume is it's big. Value is data has importance for the company, so it's valuable. Second, different data types have different kinds. There are different data types. We call them variety. So big data is various. Velocity is the speed that data comes. Usually it is fast. Veracity means truth or accuracy of the information, which often determines the executive level confidence, meaning that you have big data, but is it meaningful, and is it actually giving me something? Is it accurate? That is what we call veracity. So those are the 5 V's of big data, and first 3 is here. Oops. First 3 is more technical. It determines whether we are going to use fully automated data analysis or interactive visualization techniques. Visualize, select, filter, visualize, select, filter. So that may improve things as opposed to complete automated data analysis. So when focusing on big data, there is management part, handling part, modeling part. Here we have some visual analysis and interactive visual analysis. Also in the interpretation, evaluation, and presentation part requires information visualization. It starts with having data at low level. Then it is mapped to representations, becoming more synthetic and more clear and in a useful form. Then through the techniques, you generate reports, models, and cases for the future models, or pattern discovery and extraction using artificial intelligence or data mining methods or statistics. In the interactive techniques, there is machine learning and artificial intelligence. There's full interactive visualization. We can do browsing, searching, and monitoring. And also we can have reporting tools. These are interactive visual analytics with big data. And the previous one is automated analysis with the big data. So automated analysis is more suitable for non-research purposes. With the interactive visualization, there is selection, exploration, reconfiguration, changing, and encoding, abstraction, filtering, and connecting them, and connecting different elements and showing again, etc. So these techniques can be used in interactive visualization for reasoning. So at the end, there will be reasoning. In genetics and chemistry and protein discovery, this interactive visualization works like you select some area and click some command so that like show me something else or mark something as interesting. So this is how you interact or select the area like this. Select certain area for filtering, etc. So selecting, clicking, marking, connecting. Those are the actions that we do in interactive visualization. Also for the space research, show me different arrangements. That's one example. Connection, show me related items, and this and that selected together. Yes. We have traditional techniques and new techniques. Traditional visual analytics tools just visualize it. It doesn't properly address big data problems. There are computational problems for visual analytics tools and big data. Therefore, we need to speed up processing and also cut certain interim steps because objects are becoming large. So some automated processing and some visualization should come together. Efendim. Estağfurullah. Müsaitim, ofisteyim, dersim bitiyor. Tamam. Tamam. Oldu. So, human perception is limited and screen space is limited. So big data is not like Ocak, Şubat, Mart, Nisan, and this is the salaries, etc. Because you have too many of them. When you draw too many information in one screen, it's not understandable. Therefore, you need to filter some of them so that squeeze them into more understandable format. Therefore, big data visualization is harder than regular data visualization. Summarization is the key. Interpretation, making sense of data through inferences. So don't leave everything to user. Do some preliminary filtering by the algorithm. Also detect anomalies with machine learning and show them to user. Otherwise, those anomalies cannot be detected by eye. So person cannot detect anomalies because data is too big and too complicated. Even if you draw it, they don't understand. One is what are the techniques? Dimension reduction, clustering, machine learning algorithms, and data mining algorithms help in data visualization to reduce and compact big data into more understandable format. Let's stop here for this week because Rector is waiting for us. Let me stop recording. Where is my Discord?